So, as Eric said, I will talk about GWOSC, the Gravitational Wave Open Science Center. And this is the outline. So the idea is to try to explain you more or less what is inside our file, what are the data, what are the data set. I will talk about one thing that is called the timeline, and I will show you where to find tutorials and software. So first of all, that's the website that is the reference, GW-Open Science. So Gravitational Wave Open Science Center, this GWOSC is this nice acronym. So that's the home page that you will find if you go in this link. I highlighted the disclaimer. So the idea, our job is to not only provide the data, release the data, but also explain the user how to access to the data. So there are tutorials, there are software that you can use, and we usually put in the main page the most important news that happen, so to have immediately the new release. For example, the last thing that we published was O2, so that's why that's the first thing that you see. But I will go through the main point in the presentation. So first of all, you have heard a lot about the strain, about this quantity, this H, which is the main quantity that we measure. But it's important for us to give the user also information about the data quality, as Alan have explained you, and also about the hardware injection. The file that we provide are usually in three formats. HDF5, which is a format quite easy to read in different language. I will show you some example in Python, but okay, other languages can be used. Then we have what is called frame format, GWF, which is GW's gravitational wave frame. So it's a proprietary format of our collaborations. And then in some case, for events, also TXT file. If you open, for example, with a viewer, with, for example, HDF view, one of these files, what you will see is something like this. So you have three fields, meta, quality, and strain. Meta contains the metadata of the file. So you can imagine that it's important to know which is the detector that you are considering, which was the GPS time, and so on. Then there is the quality, as I said, of the data. And the quality is sampled at 1 Hertz. So you have one information for a second that describes the data quality of the strain. And then you have the strain itself that can be sampled at different sampling rates. I will mainly at 4 kilohertz, but recently we have released also 16 kilohertz data. So as I was saying, this is a very simple example. So okay, there are some import at the beginning. Oh, there is a part that is cut. The first letter is cut out, but you can imagine. So okay, you declare your file name, and then you make a loop to explore the key in your file. And if you execute this small Python script, you will get the three key, meta, quality, and strain that I was saying before. Then we can go on. We can load some information. So from the metadata, you can load the GPS start and the duration. Then you can load the strain. And with this simple loop, you can plot, for example, these are 2 seconds of data because I asked as number of sample. I don't know if I can do something like this. No, okay. I asked the 10,000 samples, and then since these data are sampled at 4 kilohertz, if you make the math, so you divide the 10,000 by 5, you find these 2 seconds of data. So when you do this plot, when you work with this data, you have always to keep in mind which is the sampling that you are using. So as it's been already discussed, we have had different runs of taking data, of data taking. And the last two, O1 and O2, so the first and the second observing run, were the ones when we reached the sensitivity enough to detect events. And this chart shows the past, so what have we done until now, and the color show the BNS range, so the range that the detector are able to see. And if you see that they from red you go to yellowish, it's because in these years the detector sensitivities have improved, and this allowed us to make the detections. And so that's this slide is intended to make a summary of what you find in terms of data sets in our website. So we have two different kinds of data release. We release just the data around some specific events. And this is the list of the 11 confident detection that we have at the moment. Keep in mind, when you, in terms of the name of this event, that the name is always something like GW, and then the day, but in American format. So the year, the month, and the day, which for European is a bit confusing at the beginning, but okay. And okay, this chart shows you that in 01 the detection were only LIGO detection, and then there are contribution of Virgo in 02. And all are BBH except the GW170817, which is a binary neutron star. And then in terms of bulk data release, you find beside the old run S5 and S6, and then the ones more sensitive. So 01 that was between 2015 and 2016, and 02 that was between November 2016 and August 2017. I will discuss this a bit better later. So first of all, in terms of catalog, in terms of events, if you click on the right side where there is written catalogs, or if you click on the home page where it's written catalog of compact binary, you will arrive to this page, or you can go directly to the link open science catalog. And so here you have the link to the documentation. So as I said, every release is accompanied by a lot of documentation, and in this case, for the catalog, we have 11 confident detection and 14 marginal triggers. And then also you have also auxiliary data. So in this case, you have scheme-up, samples, posterior samples, and so on. So if you go on the page that show you the confident detection, that's what you will see. I'm sorry, it's a bit cut at the extreme, but the name of the event starts always with GW, that you don't see, but okay, you can imagine. So you have a page like this that show you for each event the main quantity that characterize the event. In the upper part where there is written show hide columns, you don't see, but there is a click where you can click and change which column you want to see. At the bottom of the same page, you will see some automatically generated plot, like the one I put here. Then let's assume that you click on one of these events, the left side that is in blue. You will end up in a page like this. So you have, this case was the 11th of the 14th of August of 2017. It was a triple detection. So in this case, you have at the beginning of the page the important information, so about the source, so the luminosity distance, the masses, about the detection, so the false alarm rate, the SNR with which was detected, and so on. And then you have the list of files. In this case, as I was saying, it was a triple detection. So you have, for the three detector, V1 is Virgo, H1 is Hanford, and L1 is Livingston. And as you can notice, they are in blocks. So each of these group contain the three data type that I was mentioning before, and it's you can download the file at different length. So you have 40-second file, 40-second duration of strain around the time of the event, or 32 seconds, and you can choose 16 or 4 kilohertz sampling rate. So this altogether makes this zoo of files. The name of the file look a bit tricky, but all the letters and number have meaning. So each file name starts with the detector name, then WOSC, then the sampling rate, the release, R1, then the GPS time, and then the duration, so 32 or 4 kilohertz. And that's it. Then in terms of bulk data release, you can arrive to the page with the data release or clicking in bulk data or in download data in the home page, or just gw-open-science-data. And you will see a page like this. So when you have to download a lot of files, so we suggest to use this CERN FVM file system. So basically, this is a file system. If you click, there are a list of instructions to download the file system in your computer and basically work in the folder that contain the data as they were in your computer. Or you can click in this box that show the 4 kilohertz, 16 kilohertz data for each bulk, for each data release. And then you can have access for each data release to the documents and timelines that I will discuss a bit later. So let's assume that you click on 1, for example. This is the page where you will land. So there is at the beginning a disclaimer that explains you which was the start and stop for the run. Then you can choose, again, the slide is cut, you don't see the first letter, but you can choose the detector, which was L1. There are just two, L1 and H1, because this is O1. Then you can choose the window of time for which you can want to download your data. And then at the end you click on continue and you arrive to this other page where you see for each period the file that you can download. So all the files for this long release are contain a period of 4,000 seconds, so that's why you see a list of entries here. And you can see that not all the files have the same length. That's because, as Alan was saying, the detectors are not always on. So it's possible that the file is almost empty, because in that 4,000 piece of data taking, the detector was almost off. So that's why the last column says percent, which is the percentage of time where the detector was active in this case. Okay, so this brings to the next subject, so the segment list. So again, the detector are not always on, so you have to deal with the fact that when you download your data, you have to take care of the segments of good data that you can have. We have an instrument that is called timeline that show something like this. So you have the percentage of time that the detector is active along the data taking period. For example, in this screenshot, you have 6 segments, and you can download not only the segment where there are data, but also the segment where some specific category of data quality are fulfilled. For example, this is the timeline page that show up if you click on timeline in the page that I was showing before, the 102. So this shows again the period that we are considering. And these are 3 detectors because O2 had 3 detectors. And Virgo joined just at the last month. That's why the first part is empty. And also in H1 and L1 there are bumps, but also big holes that were the maintenance period that Alan was mentioning. And okay, I have a video that should show, yes. So you have a video that shows a bit how to play with this page, if it starts. Yes, if you click on timelines, you will arrive in this page. For example, assuming that you want to see a run, this is the page that you will see. Assume that you want to see O2. You arrive to this page where you can choose which kind of category you want to look. For example, I want to just know where there were data in H1. I don't change the start and stop, but I could. In the last part, there is this link that appears now that when you have to check all the box. And you see this timeline. Now I'm clicking because every time that you click, you zoom by a factor 2. Let's assume that I want to know which segments are in this page. You arrive to this page where you have the GPS start, stop, and the duration. But you can also download the data in the window as it was before. Okay. So, okay, this, until now I showed you how to play a bit with the website, but we also provide an API that is called Read LIGO that helps you in dealing with the data and with these segments. You can find it in the website. You just import it, like with this import, Read LIGO. And then, for example, to load the data, there is this simple command that you just provide the detector and the file, and you get this NumPy array with the time, the strain, the dictionary. And again, for the segment, you have also a method that is called getSegs, also in this case. And this flag is the data quality that you want to have. There are a lot of examples in the website. This is, for example, a short script that show you how to get this segment and plot. So in this case, I've decided the start and stop. Then I check which are the segment, and I loop on this segment, and again I plot just the first 1,000 entries, and I have a simple plots like this. And on the upper part, you see the link where to find this script on the website. So as I was saying, there is a lot of material, lots of tutorials on the website, and we usually put everything in these tutorials page. Of course, we put the most recent stuff at the beginning. In this moment, the first thing that you will see in this tutorial page is the Open Data workshop that we did in Caltech last year, and as it will be for this year. For that one, you will find all the slides, all the recording of the presentation, all the notebook of the hands-on section that you will use today. Okay, then after that, there are other tutorials. For example, these that I marked here are tutorials specifically for the event. I think they were just one event, but they show you how to use to plot, for example, the strain, how to plot the time, at the ADS. Anyway, other things that you will see in the next days. And there are other tutorials that show you how to use basic tools, Python tools to read the data and work with the segment, as I already shown you. Okay, and but as I was saying, that what I showed you now are basic Python commands, basic tools. But there are a lot of open science software that you will use in these days that helps a lot in dealing with this data. And in the software page of the website, you find links to lots of these open software that you will use in these days, and you will become familiar with. And for example, GWPy will be the topic of the next talk. Okay, and that's it. Thank you.